Good morning to all. I am Subramaniam, working as assistant professor in automobile engineering at SNS College of Technology. In this session, we are going to see about the advanced material building, advanced materials building using of the titanium and its composites. So, welding advanced materials such as titanium and composite present unique challenge but offers significant benefits in high performance industries like aerospace, automotive and medical devices. Usually, welding will be carried out in the cast iron or steels or copper and different materials as steel and copper as a tool materials also. But here we are using the titanium and composites for the welding. For the benefits of high performance in the industries like aerospace, automotive, and medical devices. These materials are highly valued for their strength, lightweight properties, and resistance to corrosion, making them ideal for applications where the performance and durability are critical. Welding titanium. Titanium is a strong, lightweight metal, excellent corrosion resistance, and high strength to weight. High strength to weight ratio. However, welding titanium is a complex due to its reactivity at high temperatures when exposed to air during welding. Titanium easily absorbs oxygen, nitrogen, and hydrogen, leading to embrittlement and weld defects. For this reason, welding titanium requires highly controlled environment, often using inert gas shielding such as argon gas to protect the weld from the contamination. Several welding techniques are suitable for titanium, including tungsten arc welding, GTAW or TIG, and electron beam welding, EBW. Tungsten arc welding is commonly used for thinner sections of titanium, offering precision control, while electronic beam welding is favored for thicker materials due to its deep penetration and minimal heat affected zone. The key to successful titanium welding is maintaining a clean, uncontaminated weld area and controlling the heat input to avoid weakening the material. Welding composites. Apart from titanium, we see about the welding composites. Composite materials such as carbon fiber, reinforced polymers, CFRP, that is carbon fiber reinforced polymers, are increasingly used in advanced engineering due to their high strength, low weight, and flexibility in design. However, welding composite is fundamentally different from the metal welding since the composite do not melt and fuse like metals. Instead, techniques like ultrasonic welding, laser welding, and adhesive bonding are used to join the composite materials. Ultrasonic welding is particularly effective for thermoplastic composites. It uses high frequency vibrations to generate the heat and bond the materials without the need for external adhesives. Laser welding and induction welding are also gaining popularity, offering precision and strong bonding without the damaging the composite structure. Finally, to conclusion, welding titanium and composite requires specialized techniques due to their unique properties. Despite the challenges, advanced in welding technologies continue to enable the successful application of these advanced materials in critical industries, offering strength, durability, and weight savings that traditional materials cannot match. And in this session we see about the advanced material welding of titanium and composites. And thank you for watching this session. We will see in the next session with another topic of weldings.